Hello students, today we're going to be talking about the crisis of infinity and confronting the infinite process. So in our last video, we uncovered the fascinating riddle that ultimately led to the birth of calculus, that haunted the birth of calculus, which is the fact that quantities that acted like shifting ghosts um, existed when we needed to clean up our math, but also vanished when we wanted a cleaner answer. But as mathematicians began digging deeper, they discovered that these tiny steps weren't the real problem. The true culprit is actually on a much larger scale, the complete opposite, which is the raw concept of infinity itself. Um, Human intuition is fundamentally optimized to handle a physical world. If I give you a basket of apples, your eyes can scan them, your fingers can count them, and your common sense operates just fine. But the moment you introduce an infinite process, I guess like a series of steps that never stops, never finishes, and just goes on forever, our standard logic starts to break down. So today we're going to be looking at why infinity defies our basic math rules. And why real analysis had to step in to establish a clear set of laws. So let's look at an intuitive ample that feels completely safe. So consider a simple line segment running from the number 0 to the number 1. You can see it clearly on your screen, and it occupies a finite space, fits inside a clean frame, and has an exact length of 1 unit. So your brain looks at this and says this is finite, closed, and it's a simple object, right? So now let's imagine that this line is a digital map on your phone and you have the ability to zoom in forever without losing detail. So let's start subdividing. If we hit the exact midpoint, it's 1/2. If we split it again, so let's just write this here, 1/2. Split it again, 1/4, 1/8, 1/16, 1/32, 1/64, so on, right? Because you can perform this division step endlessly, there is an infinite number of distinct fraction points packed inside this tiny 1-inch cube, right? So think about this contradiction for a second, right? The line is absolutely bounded on the outside. It starts at 0, stops at 1. Yet it contains an infinite set of numbers, this endless universe on the inside. So our intuition struggles because we try to treat an ongoing process that never stops as if it is static, or a finished pile of items. And early mathematicians will quickly realize that if you treat infinity like an ordinary large number, your calculations can become nonsense. So, just to see how surreal this becomes, let's look at one of the most, another famous example in mathematics, which is, what's it called? Hilbert's Grand Hotel. So, imagine a hotel that contains an infinite number of rooms, such as, room 1, room 2, room 3, and so on, stretching out forever, right? Now suppose that every single one of these rooms is currently occupied by a guest. There is a flashy light, a sign on the roof that says completely full, right? Suddenly, a new traveler walks up to the front desk, begs for a place to stay in a normal hotel with a finite number of rooms. The manager would turn them away because there's no physical space left. But in an infinite hotel, the manager smiles and says, of course, we have plenty of room, right? And all the manager does is make a quick announcement and ask the guest currently in room 1 to pack up, move to room 2, right? Room 3, and so forth, right? So until at room N, it becomes N plus 1. Because this chain of rooms goes on forever, every single current guest has a new room to sleep in. No one is kicked out into the street, right? So, yet, room 1 is now completely empty. So, the new traveler checks in and the hotel accommodates an extra person. So, this means that an infinite hotel can be simultaneously completely full on a room by room basis, yet still have infinite space to add more travelers. And if you try to apply regular arithmetic here, you get a nonsense result, which is infinity plus 1 is equal to infinity. When calculus is tearing across the scientific world in the 1700s, right? Researchers were jumping headfirst into these infinite series and processes without any safety guidelines. So they're adding up infinite long columns of numbers and manipulating infinite division, simply trusting that their intuition wouldn't lead them over a cliff. But as we've seen today, infinity does not care about our typical everyday logic. It operates under an entire different set of rules. So mathematicians cannot rely on luck or convenient coincidences. We needed a precise systematic blueprint to tame the I guess tame the infinite and make it logically rigorous. So in our next video, we're going to look at the master plan that mathematicians uh, start creating and designing to patch these foundational cracks and build a structure that can handle infinity with absolute precision. So the next video topic is going to be the blueprint of reconstruction, which is basically what real analysis is trying to fix. So I hope this video helped give you a better understanding, and I'll see you in the next video. Thank you.